Last class we discussed about magnetism and the theory hidden behind the magnetic properties, evolution theory of magnetism, right? And magnetism properties, as well the magnetic lines of forces, isn't it? So now we will discuss magnetic flux density, uniform and non-uniform magnetic field sometimes. So those definitions we have to learn. Coulomb's inverse square law, and there a problem on it also we have to discuss, so you could understand the how to solve the problems based on the forces caused due to the what inter poles, right? That means the force of attraction between the two poles, or sometimes the distance between the two poles, right? Either repulsive force or attractive force, right? And okay, so we'll enlarge the phone, right? Now let me take this video so it will be clear somewhat. Okay. So children, now let me tell you the uniform magnetic field and non-uniform magnetic field. So suppose in the earlier class I told you the definition of magnetic field. What is magnetic field? The region around the magnet or magnetic influence felt, where the influence of magnetism is felt, is called magnetic field. That means kshetram antam Telugulo, isn't it? So kshetram ante or paridhi, the boundary below which the magnetism can be felt by the magnet, the region around which it can felt the magnetic effect. So here uniform magnetic field and non-uniform magnetic fields, two are there. So a magnetic field is said to be a uniform if the magnetic lines of force have the same magnitude and the same direction at all the points in the region. That means if the magnetic lines of forces or the magnitude of the magnetism is same or equal at all the points, and the lines must move in the exact direction, so then that region is said to be a uniform magnetic field region. An example, if you see that wide area is the earth's magnetic field, uniform magnetic field over the wide area is the earth's magnetic field. So in case in the earlier class I told you, I have shown you the magnetic lines of forces parallel to the bar magnet, a rectangular frame I told you in the previous class. So parallel to the bar magnet there is possible to having the uniform magnetic field. Why? Because all the lines will be parallel. Maybe the densities of the lines of forces may increase, but the lines you can see that those all are in parallel direction, and the lines of forces are moving from north to south. The magnetic lines of forces moving from north to south, and they are parallel to the magnetic field, isn't it? And uniform non-uniform magnetic field definition I can define here. The magnetic field is said to be a non-uniform if the magnetic lines of forces vary in their magnitude and direction at different point in a region. Yeah, so here the example is the same magnetic magnet where the lines of forces can be seen at the poles. అంటే పోల్స్ దగ్గర మనం చూసినట్లయితే నార్త్ పోల్ కానీ సౌత్ పోల్ కానీ మ్యాగ్నెటిక్ లైన్స్ ఎట్లుంటాయమ్మా, అక్కడ ఆ మ్యాగ్నెటిక్ లైన్స్ నార్త్ నుంచి సౌత్ వైపు వస్తుంటుంది. సౌత్ పోల్ దగ్గర దే ఆర్ అప్రోచింగ్ అండ్ దట్ మీన్స్ రిసీవింగ్ ఫోర్స్ and are acquiring force. Then north pole దగ్గర the forces are being released out, the forces are being lines of forces are being moving away from that pole, and at the south pole they are lines of forces are moving towards the pole. So this is the non-uniform magnetic field there, and the density of lines of forces will be large and the direction will be in a different, but parallel to the magnet can be seen at parallel, the lines can be seen, the uniform magnetic field can be seen parallel to the magnetic field or magnet, but non-uniform magnetic field cannot be seen at the parallel, but they can be seen at where poles, at poles. Okay, so in the non-uniform magnetic field, the magnetic lines of forces are not parallel, they are curved, they are in curved nature, right, parabolic nature or curved in nature. Okay, now so next you must know that magnetic induction field strength. So before that uh, I will tell the magnetic flux density. So the amount of magnetic flux through a unit area taken perpendicular to the direction of magnetic flux is called magnetic flux density. Okay, magnetic flux or magnetic flux density, both are same. So the amount of magnetic lines of forces passing through one area perpendicular to it, that is called as magnetic flux. Flux is nothing but number of lines of forces passing through a unit area, and the lines are perpendicular to that area which we have designed, or where the point where we want to know, right. So the magnetic flux density is related to the magnetic field H by the and given by B is equal to mu H. In the earlier class I told you B is equal to psi into H, where psi is a susceptibility. Psi is a susceptibility. So here the Greek letter X, instead of X you will write psi there. So the magnetic flux density susceptibility is denoted by what we call psi, and here magnetic flux density is denoted by mu, and here in that case B is equal to psi H, and in this case B is equal to mu H, and magnetic permeability, it is denoted by letter R. Okay, small r. So later we will discuss that, where mu is the permeability of the medium or material, or we are measuring the field. So the magnetic flux density is measured in Webers per square meter, Weber per meter square, or Weber per square meter, or simply Tesla or Tesla. The magnetic field induction, the magnetic flux density is a vector field, which means it has magnitude and direction at each point in a space. So children, a magnetic flux density is also sometimes called as magnetic induction field strength. Magnetic induction field strength. The force experienced by the unit north pole placed at a point in a magnetic field is called magnetic induction field strength. So B is equal to F by M. B is equal to F by M. That means mu naught by 4 pi M by D square. This is the formula actually. B is equal to F by M, where F is a mu naught by 4 pi D square. That is the force of attraction or repulsion. Okay. And the unit of B is a Weber per meter square. The unit of B is a Weber per meter square, or sometimes called as Tesla. And the dimensional formula is M L0 T power minus 2 A inverse. Okay. So some charge is been flown here. So that's why the either positive or negative charges, due to that the spin of the charges, some current is being generated here. So that's why ampere is the unit which involved in this dimensional formula. I repeat again, M L0 T power minus 2 A inverse. Right. Next. Okay, that is not ampere actually, area. Then coming to poles, as I said earlier, pole strength. uh, right. So children, coming to pole strength, uh, pole strength is a measure of amount of force exerted by one of the pole of the magnet to pole of the other magnet. So the force can be attraction or repulsion. Here, no need of taking one force, either repulsion or uh, either attraction. The force existed or exerted, sometimes we term. So the force is exerted by the unit north pole or south pole of a magnet, or either of one, either of both one, then that strength of the experience force experiencing at that pole is called pole strength, and it is denoted by letter small m. If the two poles are there, we have to consider m1 and m2 for poles, and uh, the unit of pole strength is ampere meter. Unit of pole strength is ampere meter. So here why I am discussing about pole strength means, in case of Coulomb, the force of attraction or repulsion between two magnetic poles is directly proportional to the product of pole strength and inversely proportional to square of distance between them. Right? So in this Coulomb's inverse square law of magnetism, what's happening actually? So before that, let me go. Yeah. So I repeat the pole strength's definition again here. The the measure of force exerted by one face of the magnet on a face of another magnet is nothing but pole of the one magnet to pole of the another magnet, when both magnets are represented by equal and opposite poles, and it is denoted by small m, children, and ampere meter is its units. Ampere meter is its units. Right. Now, magnetic induction field strength is nothing but B is equal to uh, mu into H, or sometimes B is equal to pi A, where A is the area uh, normal to the lines of induction, where A is the area, and in some books you may get B is equal to pi by A, and in some books you may get B is equal to mu naught by 4 pi d square, right, into H. So all different books, authors, they may denote with the different letters, but according to this Coulomb, Coulomb studied the force of attraction and repulsion between the magnetic poles, and he summarized the result, and he stated one condition: the force of attraction or repulsion between the two magnetic poles is directly proportional to the product of their pole strength and inversely proportional to the square of the distance between them. That means he has taken two poles. Okay, let us consider two poles, or a bar magnet with the north pole on left side and south pole at right side. Let the magnets be placed at a distance of d. Okay, the two poles distance, the distance between the two poles వచ్చేసి d అనుకుందాం. Then mathematically, according to his theory or statement, I can write that force is proportional to m1 into m2, the product of their pole strength, and force is inversely proportional to the square of the distance between them, and F is also proportional to 1 by d square. Therefore, F is equal to mu naught by 4 pi m1 m2 by d square, where m1 and m2, here I have taken q1 q2. q1 q2 are the pole strengths. అయితే కొన్ని బుక్స్లో m1 m2 తీసుకుంటారు చిల్డ్రన్, అండ్ కొన్ని బుక్స్లో q1 q2 తీసుకుంటారు. సో డిపెండింగ్ ఆన్ ద author's style. So where m1 and m2 are the pole strength and two poles, and r is the distance between the two magnetic poles. In some books they will take d, and some books they will take r. In some books they will take the radius as r, and some book they take the radius as x or d, isn't it? So it depends on their style, other style. Now where k is a proportionality constant whose value depends on the surrounding medium in SI units, whose uh, where k is a proportionality constant whose value depends on the surrounding medium in SI units. The value of k for the free space is, where the value of k for the free space is mu naught by 4 pi, and the value of mu is equal to mu naught by 4 pi is equal to 10 power of minus 7 Henry per meter. 10 power minus 7 Henry per meter. Recently he asked a question based on the Coulomb's inverse square law, children, in the last class. I think no, not only last class, in internal mid 1 and mid 2, sorry, mid 2 and last end exam, and recently for again the same problem is been asked based on the Coulomb's inverse square law in supplementary June also. So in from that figure generally we by using this formula what I can found is I can find a force of attraction or repulsion between the two pole strength, or sometimes if force is known then pole strengths, unknown pole strength can be determined. Sometimes distance between two poles can be determined if the pole strengths are given and force between the two magnetic poles is given. Okay, you go through this formula, right? So mu naught by 4 pi m1 m2 by d square, where mu naught by 4 pi value is equal to 10 power of minus 7 Henry per meter. Henry per meter, right? Coulomb's inverse square law statement also you have to note it. The force of attraction or repulsion between the two magnetic poles is directly proportional to the product of their pole strengths and inversely proportional to the square of the distance between them. So mathematically we can write k is equal to mu by 4 pi 10 power minus 7 Henry per meter, where MA and MB are pole strength of magnet A and pole strength of magnet B. If MA is equal to MB, that means if two poles are same, then you will get the force of repulsion. If two poles are opposite, then you will get the force. We can see the uh, attractive forces between those two poles. Now, yeah, sometimes in books, in some books he may give F is equal to K QMA QMB by R square into R cap. That is vectorial form representation of Coulomb's inverse square law. Biot Savart law kuda manam atle rastam in case of Biot Savart law also. But in magnitude, in vectorial form, equation 3.7 is right. That means K Q M1 M2 okay, M1 K MA MB, and in some books R cap would ichcharu student. R cap is also a radius or distance between the charge poles. Okay, in magnitude F bar is equal to K into QMA QMB by R square, right? Okay, Now, consider two bar magnets. Consider two bar magnets. So, yeah. Uh, Consider two bar magnets A and B as shown in figure, and when the north pole of a magnet A and the north pole of magnet B are the south pole of magnet A and the south pole of magnet B are brought closer, they repel each other. On the other hand, when the north pole of magnet A and the south pole of magnet B or the south pole of magnet A and the north pole of magnet B are brought closer, the poles are attract each other. అంటే ఇక్కడ ఏం లేదు, ఇక్కడ ఏమంటాడు, when the what we call opposite poles attract each other, opposite poles attract each other, and the uh, same poles, like poles, unlike poles attract each other, like poles repel each other. అదే చెప్తున్నాడు ద కాన్సెప్ట్లో, రైట్. by 4 by 10 power minus 7 Henry per meter. This is K value. Okay. Now, in unit, opposite charge attract and like charge repel each other. So, analogous to Coulomb's law in electrostatics, we can state Coulomb's law of magnetism as follows. Okay, figure చూడండి, static charges, these are the magnets. ఫిగర్ చూడండి, okay. Sometimes what static charges, this is a figure children. So fine wire, glass cylinder, magnet, that is also a magnet, P1 P2, south and north, pole strength P1 and P2, fine wire is there, glass cylinder is there. Now how they act, the figure చూస్తే మీకు అర్థమవుతుంది. You have to look this figure carefully and understand the concept. Try to understand the concept children. ఈ ఫిగర్లో మీకు ఏమర్థమవుతుంది, ఒక నార్త్ పోల్ ఉంది, ఒక సౌత్ పోల్ ఉంది. సో నార్త్ పోల్, one magnet is placed vertical and another one is in horizontal with help of fine wire. So now naturally one bar magnet north and north gets repels. ఈ రెండు ఇప్పుడు ఈ ఉన్న ఫిగర్లో దీని ప్రకారం చూస్తే మీకు ఏమవుతుంది, ఫ్రమ్ ఇన్ ఎ సిలిండర్ వెన్ దిస్ నార్త్ పోల్ P1 అండ్ P2 పోల్ స్ట్రెంత్ రెండు కూడా రిపల్సివ్ ఫోర్సెస్ ఉంటాయి ఇప్పుడు, ఎందుకంటే నార్త్ అండ్ నార్త్ మ్యాగ్నెట్స్. వెన్ దిస్ ఈజ్ రొటేటెడ్ అండ్ సౌత్ పోల్ ఈజ్ బ్రాట్, సౌత్ పోల్ని కనుక ఇలా తీసుకొచ్చామనుకోండి, ఇప్పుడు ఎక్కడికి ఆపోజిట్ డైరెక్షన్లో చేంజ్ చేసామనుకోండి, దెన్ దెర్ ఈజ్ అట్రాక్షన్, then definitely this bar magnet will get attracted to the south one. That means the bar magnet which is hanged or which is lifted by the horizontal wire, hanged by the vertical wire, that will get attracted to the vertically placed magnet, and if north pole is brought together to the north pole of the vertical bar magnet, then it avoids, it moves just from there, isn't it? ఈ ఫిగర్ మీరు చూస్తూ, దిస్ ఇస్ ఎక్స్పెరిమెంట్, ల్యాబ్ ఎక్స్పెరిమెంట్ విచ్ ఇస్ టు బి డన్. ఫిగర్ చూడండి, అండ్ యూ విల్ అండర్స్టాండ్ దట్ వాట్ attractive forces and repulsive forces. Repulsive force and attractive forces student. North, south. A red color is denoted by the north, and blue, navy blue color or indigo color is denoted by letter S. Magnetic poles behave like a electric charge. Like poles repel and unlike pole attract. Okay. So in this figure, student, okay, in first figure, in a cylinder, glass cylinder, you could see the Coulomb's inverse square laws verification or identification or observation, whatever you call, with the help of this cylinder. Then in the second down, north and north poles are there repulsing. Two north poles, when they brought together, an adjacent figure you see, they are repulsing. And in the next case, first one is repulsive, magnet A, magnet B. What is happening when they brought together? They are repulsing each other. Then in the second case, south and north brought together, they are attracting each other. They are attracting each other. Right? Right. Repulsion force, attractive force. So now ఏమంటారు ఇక్కడ, Coulomb's inverse square law. According to Coulomb's inverse square law, what it states, the force of attraction or repulsion between the two magnetic poles is directly proportional to product of their pole strength and inversely proportional to square of the distance between them. అది చూపించడానికే దిస్ ఈజ్ ద ఎక్స్పెరిమెంట్. సో ఈ స్టేట్మెంట్ మనకు చూపించడానికి దిస్ విల్ బి యువర్ ఎక్స్పెరిమెంట్. డిస్టెన్స్ బిట్వీన్ టూ బార్ మ్యాగ్నెట్స్ ఎక్కడ, థర్డ్ ఫిగర్లో, ద ఫస్ట్ ఫిగర్ కాకుండా, ఫస్ట్ ఫిగర్ యూ క్యాన్ సీ, ఇన్ సెకండ్ ఫిగర్ యూ క్యాన్ సీ ద డిస్టెన్స్ ఈజ్ ఇంక్రీజింగ్ అండ్ హియర్ డిక్రీజింగ్. దిస్ డిస్టెన్స్ arrow marks the distance between two poles will give you a D, right? Now next we will solve some problem. Okay, చూడండి, consider when a north pole of magnet A and north pole of magnet B, or the south pole of A and the south pole of B are brought closer, they repel each other. I'll take now a bar magnet and I will solve the problem, so you will get an idea. Now solution, the yeah, you see the problem. Problem చూడాలి children. Based on this formula, ఫార్ములా ప్రకారంగా మనకు Coulomb's inverse square లా ఏమంటారంటే ఫోర్స్ F is equal to mu by 4 pi m1 m2 by d square. ఆ ఫార్ములా ప్రకారంగానే మనము సాల్వ్ చేస్తాం ఒక ప్రాబ్లమ్ని. Now ఏ ప్రాబ్లం తీసుకున్నా now I will take one problem and solution. The repulsive force of two magnetic poles in air is 9 into 10 power minus 3 children. If the two poles are equal in strength and are separated by a distance of 10 centimeters, then calculate the pole strength of each pole. Calculate the pole strength of each pole. So if two equal strengths, అంటే here m1 and m2 they are equal. సో మనకేం చెప్పాడు, ఫోర్స్ బిట్వీన్ ద టూ పోల్స్ ఈజ్ గివెన్ ఇట్ సిమ్స్, అండ్ F is equal to 9 into 10 power minus 3 newtons, R is equal to 10 centimeters, that means 10 into 10 power minus 2 meters. Why I am considering meters? Here the force is given in newtons. Force దేంట్లో ఇచ్చిండమ్మా, న్యూటన్స్లో ఇచ్చిండు. ఫోర్స్ని కనుక మనకు న్యూటన్స్లో కాకుండా డైన్స్లో ఇచ్చుంటే దెన్ వీ యూస్ టు గో డైరెక్ట్లీ, we are supposed to go with centimeters given data. But here the force is given in newtons, so we have to convert in meters. Newtons అనేది MKsలో ఫోర్స్ యూనిట్, isn't it? So Newton is the unit of force in MKs system. But if you would have given in dyne, then I would have taken the same. R is equal to 10 centimeters, 10 into 10 power minus 2 meters. So therefore I can write 9 into 10 power minus 3 is equal to 10 power minus 7 into qm square by 10 into 10 power minus 2. 10 gets cancelled. 10 power minus ఇది 10 square, 10 power minus 4, అంతే కదా. Okay, to see this, 9 into 10 power minus 3 is equal to 10 power minus 7 into qm square. Here qma qmb both are equal కాబట్టి నేను qm square అని రాసేసిన. Actually formula is a F is equal to mu naught by 4 pi value of 10 power minus 7 which is equated into qm into qmb whole square by r square. So qm into qma by qmb by qma into qmb by r square. So qm is equal to qmb కాబట్టి qm whole square రాసేసిన. Then r value is 10 into 10 power minus 2, so I have substituted 10 into 10 power minus 2 whole square, where its value is 10 square, isn't it? 10 square, and here its value is 10 power minus 6 minus 5. So 9 into 10 power minus 3. So that is 30 newtons Tesla. So now I will take another experiment. another example, children. So if I take another example to solve this problem, yeah, another example I will tell. I'll take another example problem so that you will get an idea. Now, so లాస్ట్ ప్రాబ్లం మనకు వచ్చినటువంటి ప్రాబ్లం ఎక్కువ మందికి ఇదే వచ్చింది ఎక్కువ మట్టుకు. సమ్టైమ్స్ సో two magnets of pole strength 40 ampere meter and 20 ampere meter are separated by a distance of 0.2 meters in air. Calculate the force between them. Please you note down this problem. Two magnetic poles of pole strength 40 ampere meter and 20 ampere meter are separated by a distance of 0.2 meters in air. Okay. Calculate the force between them. So here the pole strengths, two pole strengths are there. One pole strength M1 is equal to 40 ampere meter, another pole strength M2 is equal to 20 ampere meter. Distance between them is 0.2 meters. So if it is given 20 centimeter, you have to convert into meters because pole strength value is given in ampere meter kabatti. And the force between the poles F is equal to how much? You are well known the formula F is equal to mu naught by 4 pi. So mu naught by 4 pi మీరు వాల్యూ ఏం చేయాలంటే you have to substitute 10 power minus 7 directly. 10 power minus 7 into 40 into 20 by 0.2 whole square. That means 40 into 20 800. 800 by 4 into 10 power minus 2 or 0.04 you can write. So 4 into 10 power minus 2. So 10 power minus 2 and 10 power minus 7. You will get 10 power minus 5. అంతే కదా. So again hundreds are there. So 10 power minus 3. So force is equal to 10 power minus 3 newtons. So similarly, sometimes he may ask you the ratio of the length of the 2-bar magnet is sometimes he may ask you force between the two magnetic poles is 50 into 10 power minus 7 newtons. Find the force when the distance between them is doubled. That means if distance between them is doubled, distance between them is halved. These questions are very, very expected questions. So to get confused, how to take? If they asked force between the distance between them is doubled, then you have to simply write d1 is equal to d and d2 is equal to 2d. If it is halved, d1 is equal to d and d2 is equal to d by 2. So if I discuss one problem here, the force between the two magnetic poles is 50 into 10 power minus 7 newtons. Find the force when the distance between them is doubled. So the force between the two poles F1 is equal to 50 into 10 power minus 7 newtons, children. Now distance between the two poles is doubled. d1 is equal to d and d2 is equal to 2d. New force between the magnetic poles F2 is equal to how much? So formula F1 by F2 is equal to d2 square by d1 square. ఎందుకు రాస్తున్నాను d2 square by d1 square? F1 is equal to mu naught by 4 pi m1 m2 by d square. So we need not to take all m1 m2 1 by d square, you have to take, that's all. So F1 is equal to 1 by d1 square, F2 is equal to 1 by d2 square. Then F1 by F2 is equal to d2 square by d1 square, that's all. అంటే 1 by d1 square divided by 1 by d2 square. So ultimately you will get d2 square by d1 square. So f1 is given 50 into 10 power minus 7, but f2 is not given. We have to find out. d2 is given 2d double kada, so 2d whole square by d square. So 4d square by d square వస్తుంది. So d square gets cancelled, denominator and numerator. Then you will get 4f2 is equal to 50 into 10 power minus 7, but f2 is equal to 12.5 into 10 power minus 7. అంటే ఎన్ని రేట్లు తగ్గింది? 4 times డిక్రీజ్ అయింది. ఎంత తగ్గింది? 4 times డిక్రీజ్ అయింది చిల్డ్రన్. సో వెన్ ద డిస్టెన్స్ బిట్వీన్ ది పోల్స్ ఈజ్ డబుల్, న్యూ ఫోర్స్ f2 ఈజ్ ఈక్వల్ టు 12.5 into 10 power minus 7 newtons. Sometimes force is doubled, then how much distance it has decreased. అంటే ఇక్కడ ఏమంటారు? ఫోర్స్ బిట్వీన్ ద టూ మ్యాగ్నెటిక్ పోల్స్, ద డిస్టెన్స్ బిట్వీన్ ద టూ మ్యాగ్నెట్ ఈజ్ సో అండ్ సో అని ఇచ్చేసి ఫైండ్ దిస్ సెకండ్ డిస్టెన్స్ వెన్ ద ఫోర్స్ హ్యాస్ బీన్ డబుల్డ్ ఆర్ ఫోర్స్ హ్యాస్ బీన్ డిక్రీజ్డ్ ఆర్ ఫోర్స్ హ్యాస్ బీన్ ఇంక్రీజ్ 2 times. అట్లాంటి కండిషన్స్ వస్తుంటాయమ్మా. సో వీ హ్యావ్ టు బీ కేర్ఫుల్, రైట్? అండ్ దిస్ ఈజ్ ద topic today which we have discussed, that is magnetic flux density or magnetic induction field strength అంటారు దీన్నే. magnetic induction field strength అన్న magnetic flux density అన్న ఒకటే. then Coulomb's inverse square law, very very important one for finding out the force between the two magnetic poles, strength poles, or finding the distance between the two poles. Okay, and the next one is a problem we have solved it. In the next class we will discuss, we will come forward with another topic. Okay, see you children, bye.